Have you ever really stopped to think about what happens to the internet? Not just tomorrow, but say, in 100 years? We treat our digital world like it's permanent, etched in stone. But what if it's really more like writing in the sand, constantly being washed away by the tide of technology? Well, today, we're going on a journey into the incredible and often invisible battle to save our digital heritage from just disappearing forever.
44. Just think about that number for a second. In the grand scheme of things, what could it possibly mean? It's not a version number, it's not some anniversary, it's a lifespan. And it is shockingly, unbelievably short.
Yep, that's right. Back in the late 90s, the average web page lived for only 44 days. A piece of the early internet, someone's passion project, a news story, a whole community, could be born, live its entire life, and then vanish. Completely vanish, in less time than it takes for the seasons to change. This isn't ancient history, folks. This is the foundation of the world we live in now, and it's been quietly crumbling from the very beginning.
And this quote from Dale Flecker at Harvard just hits the nail on the head. We can all picture it, right? That stack of old magazines in the attic, tangible, physical, maybe a little dusty, but they're there. You can still read them. But our digital culture, it doesn't have an attic. It doesn't get old and yellow. It just breaks. It becomes inaccessible, a ghost in the machine.
So how in the world do we fight this digital decay? Well, here's the roadmap for our deep dive today. First, we'll look at the very real threat of a new dark age. Then we're going to tackle the wild challenges of saving the web, ebooks, and our digital media. We'll also uncover an amazing plan to build a digital ark. And finally, we're going to ask the biggest question of all. Is any of our digital memory truly safe?
The idea of a digital dark age sounds like something out of a sci-fi movie, doesn't it? But it is a very real threat that archivists and librarians have been sounding the alarm about for decades. See, unlike a clay tablet or a book, which can survive for centuries through sheer neglect, digital stuff needs constant, active work to keep it alive. Without that effort, we risk leaving a giant black hole in our own history.
And this really gets to the heart of the problem. With analog stuff, the information is physically part of the object. You can hold a photo, you can feel the grooves on a record. But with digital, the message is the code. A file is just a bunch of ones and zeros. It's totally meaningless without the exact right hardware and the exact right software to make sense of it. And that technology, it has a brutal, unforgivingly short shelf life.
So you can imagine, the first great frontier for this fight was the internet itself. Back in 2002, when a lot of these foundational ideas were being mapped out, experts were trying to figure out how you could possibly archive something that was less like a library and more like a living, breathing organism that was changing every single second. It seems like such a simple question, right? What is a web page? We look at them all day. But if your job is to preserve one forever, it's actually a deceptively tricky question. What part of it do you even save to capture what it really was? Because you see, a web page isn't one thing. It's a package of all these interconnected parts. You've got the stuff you see on the surface, the text, the pictures, but underneath that, the average page back then had about 15 links pointing out to the rest of the web. It was pulling in sounds or videos from totally different places. And a lot of the web was being generated on the fly from hidden code and databases, what people call the deep web. To save the page, you have to save that whole ecosystem. And this led to this huge debate between two camps. On one side, you have the librarians. They're thinking, okay, the content is the important thing. The article, the picture, that's what we save. But on the other side, you have the computer scientists, and they're saying, whoa, 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 the real magic of the web isn't the pages, it's the links between them. The web is a system. To them, saving the page without the links misses the entire point.
Which leaves us with this massive philosophical question. If you save a page, but the link you click leads to a dead end, a 404 not found, is the archive broken? Is the original context just lost forever? This is the kind of puzzle these digital archivists are trying to solve every single day. Okay, so the open web is the Wild West. What about something that seems more contained, like an ebook? You'd think that would be easier to save, right? Well, it turns out they come with their own, unique set of infuriatingly complex problems. The early days of ebooks were just pure chaos. I mean, you had dozens of competing file formats that only worked on specific devices. You had these complex copy protection schemes, DRM, that were designed to stop you from sharing, but also made it nearly impossible to preserve. And the ebooks themselves were getting more complex, mixing text with audio with video. It was an absolute preservation nightmare.
And you can literally see the industry trying to wrestle this chaos into some kind of order.
This timeline shows this frantic 4-year scramble where all these different groups raced to create a common language for ebooks. Standards for file types, for numbering, for metadata, all in a massive effort to make sure that an ebook you bought today might actually be readable in 10 years.
But look, if preserving text is hard, saving digital audio and video is on a whole other level of difficulty. It's not just that the files are huge, it's the sheer complexity of the formats and how they're made that creates the real challenge. This description from public broadcasters just nails it. A modern TV show isn't one thing, it's a great threaded mesh. You've got brand new digital footage, spliced with old analog film, scanned photos, computer graphics, multiple audio tracks, all woven together so tightly that figuring out what the original version to be saved even is becomes almost impossible.
And here we are again with another number, 17 plus. And just like our 44 from the beginning, this number tells a story of absolute technological chaos.
Get this, in just 15 years, the professional broadcast industry rolled out over 17 competing and mostly incompatible digital videotape formats. The format problem alone is a nightmare. Each of those tapes needs a specific physical machine to play it back, and guess what? A lot of those machines are already museum pieces. They're obsolete, you can't get parts, so an archive might have a perfectly good tape with absolutely no way to play it.
And then there's the size. I mean, just look at this chart. The jump in data from old-school standard TV to high definition is mind-boggling. We're not talking a small increase, we're talking a monumental leap. A single hour of uncompressed HD TV can be 100 gigabytes. Now multiply that by the entire history of television. The storage problem alone is absolutely staggering.
And this is what's really at stake. The former head of the Library of Congress said this way back in 1997, and it's a truly chilling thought. Our cultural history shouldn't be left to pure chance. The idea that future historians trying to understand our time will only have fragments and scraps because we couldn't figure out the logistics, that's a failure we just have to avoid.
So facing this tidal wave of problems, the U.S. Congress gave the Library of Congress a mission: figure this out. And what they came back with was this incredibly ambitious blueprint for a national strategy, a plan to build a kind of digital ark to survive the coming storm of technological change.
And they knew they couldn't do it alone. I mean, look at this roster. To tackle this, they assembled an absolute dream team. You've got tech titans like Microsoft and the founder of Netscape. You've got publishing giants like Random House. You've got major foundations in the nation's top archives all at the same table. This showed it wasn't just a library problem, it was a national challenge.
Now, at the technical heart of the plan were two competing ideas. First, you've got migration. Think of this like translating an old book into modern English every few years. You just keep updating the file so new computers can read it. It works, but you might lose a little something in the translation. The other strategy is emulation. This is more like building a perfect simulation of an old computer so you can experience the original file exactly as it was. It's perfectly authentic, but as you can imagine, it is way more complex.
And the blueprint they laid out was this brilliant 4-layer system. Let's build it from the ground up. At the very bottom, you have repositories. These are like secure digital warehouses, just storing the raw ones and zeros. Next up, gateways. They're the traffic controllers, managing access. On top of that, you have the collections layer. This is the real brains of the operation, holding all the rich metadata, the card catalog for every object. And finally, at the top, you have the interfaces, the websites and tools that let you and me actually find and use the stuff. It was a beautiful, distributed network.
So that was the big plan from over 2 decades ago. It was visionary. It identified the core problems and proposed a really sophisticated solution. But that just begs the question, right? Where are we today? After all that, is our memory safe?
Well, the hard truth is, the big challenges from 2002 are all still with us. And in a lot of ways, they've just gotten bigger. The amount of new content being created is it's overwhelming. Copyright is still a legal minefield for archives. The very idea of what a document even is keeps changing. And of course, getting the long-term, stable funding needed for this work is a constant, massive struggle. And that brings us right here to the present. That 2002 blueprint, it wasn't just a paper. It led to real programs and real tools that are still in use today. The idea of a distributed network is basically the DNA of things like the Internet Archive's Wayback Machine. But the brilliant people who wrote that plan, they couldn't possibly have imagined a world of infinite scroll TikTok feeds, of AI generating content out of thin air, of entire virtual worlds in the metaverse.
Each one of these things presents a preservation challenge that is exponentially harder than a static web page. So while the battle continues, the ghost of our digital present is being created every single second. And the real question is, are we doing enough to make sure anyone in the future will even be able to see it?